This video is presented by AmazingPhysicsForAll.com. Satyendra Nath Bose, also known as S.N. Bose, was an Indian mathematician and physicist who founded what is now known as Bose-Einstein statistics. Later, Einstein extended Bose's ideas to atoms and predicted an exotic state of matter, Bose-Einstein condensate. Though Bose did not receive the Nobel Prize for his discovery, later there were 7 Nobel Prizes awarded to discoveries in the field, which started with Bose's discovery. Before getting into the details of his discovery, we should review the history of what was going on at the end of 19th century in the world of physics and technology. Unbelievably, it all started with building more efficient bulbs. In the first half of the 19th century, in the UK, Michael Faraday demonstrated the concept of dynamo and electric motor. Scottish scientist James Maxwell predicted the existence of electromagnetic waves that travel at the speed of light. Heinrich Hertz, in Germany, experimentally verified the existence of electromagnetic waves. All those groundbreaking discoveries resulted in technological innovations like telegraphy, electric motor, and dynamo in the second half of 19th century. Incandescent light bulb was one of the inventions in this series of innovations. In 1880s, German companies tried to develop more efficient light bulbs than their American and British rivals. This required a full understanding of the relationship between the temperature of a body, the range of light colors a body emitted, and their light intensities. For instance, consider putting an iron rod in a fire. What happens? As the rod becomes hot, it turns red. If you continue to leave the rod in the fire, it gets hotter and hotter, and then the rod's color changes from red to orange, then yellow, and finally a bluish-white. The question physicists had was what the relationship between the temperature, the color of the light, and the intensity of radiation was. This field of study in physics is known as blackbody radiation. Blackbody radiation graph. In 1887, the German government founded the Physikalische Technische Reichsanstalt, PTR, in Berlin. The need to make a better light bulb was the driving force behind the PTR's blackbody research program in the 1890s. This research ultimately resulted in the discovery of quantum and opening a new field in physics, quantum mechanics. German physicists like Gustav Kirchhoff, Wilhelm Wien, Lummer built several equipments to study the problem of blackbody radiation. They carefully studied the relationship between a body's material, a body's temperature, wavelength of the light it emitted, and the intensity of the emitted light. And they plotted their experimental data in a graph. The graph was similar to the one shown here. The graph illustrates the relationship between the temperature of a body and the spectrum of radiation it emits and the intensity. At relatively low temperatures, the emitted radiation is mostly in the infrared region. As the temperature increases, the maximum intensity shifts to shorter wavelengths, successively resulting in red, orange, yellow, and finally bluish-white light. Planck's equation. Max Planck, a professor of theoretical physics at Berlin University, was puzzled by their findings. In 1900, in order to explain the experimental results, as a desperate attempt, Planck heuristically arrived at an equation. But the derivation of his equation, based on classical Boltzmann statistics, was not satisfactory. Though the equation perfectly matched with experimental data, Planck himself was not happy with it, as he could not derive logically based on classical statistics. Bose's quantum statistics. In 1924, S.N. Bose, as a reader in the physics department of Dhaka University, while preparing for a lecture to his students on Planck's radiation equation, realized that the derivation was not adequate and sound. He questioned the basis of applying classical, Maxwell-Boltzmann, statistics which assumed that every particle was unique and distinguishable. Instead, Bose argued that light particles, photons, of a particular frequency must be indistinguishable. Using this groundbreaking idea, he modified the derivation to arrive at Planck's equation in a most coherent and elegant way, without Bose himself realizing that he founded a new field, quantum statistics. Einstein's recognition. When Bose tried to publish his research finding in the Philosophical magazine, it got rejected. Bose then sent his research paper to Albert Einstein. Einstein instantly recognized the physical importance of his great idea. Einstein not only translated Bose's paper in German but also got it published in Zeitschrift für Physik. The statistics that Bose discovered is now known as Bose-Einstein statistics. The class of particles that obey Bose-Einstein statistics are now called bosons, in Bose's honor. For instance, photon, the light particle, is a boson. Einstein later adopted Bose's idea and extended it to atoms to discover an exotic phenomenon, Bose-Einstein condensate. Though Bose did not receive the Nobel Prize for his groundbreaking idea, half of the particles in the universe are named bosons, in his honor. Please subscribe and give a thumbs up if you like this video. And if you would like to read more on similar topics, please visit AmazingPhysicsForAll.com. Thanks for watching.